Hello friends, welcome again. Today's question is, we are given a circuit here, okay, and in this circuit the switch S is closed at t equal to 0 and we are asked to find the value of inductor voltage at t equal to 0 plus, okay. So how to proceed for this question? So t equal to 0 plus means just after switch is closed, just after switch S is closed, okay. So this is that switch, okay. So you can observe here that there is a capacitor and there is an inductor, and the voltage of the inductor has to be calculated just after the switch is closed. So how to proceed for this question? So this can be done by using a property which says that capacitor opposes instant change in voltage, okay. So the capacitor will not allow instantaneous change in voltage, okay. So whatever was the voltage just before the switch is closed, the same voltage will be across the capacitor just after the switch is closed, that is at t equal to 0 plus. Same thing, the inductor opposite instant change in current, okay. So the current will be the same as it was before the switch was closed and after the switch is closed, that is at t equal to 0 plus. So before switch S is closed, so you can see that the circuit looks like this, okay. So there is isolation from the voltage source, okay, and you can see this is 4 ohms, this is 3 ohms, and again this is 4 ohms, and this is the inductor. Now you can see here that since there is no source present, the voltage across the capacitor is 0, okay. If I call this voltage as VC, okay, VC, so this voltage VC of t at t equal to 0 minus, that is just before the switch is closed, I can say it is 0 volts. Same the inductor current, okay, that is 4 Henry inductor, okay. This current, if I call this current as I of t, okay, this current I of t at t equal to 0 minus is equal to 0 amps, okay. Now as the switch is closed, the current should not change instantly, as this is the property of the inductor. So this current is equal to I of t at t equal to 0 plus. Similarly, the voltage also should not change as soon as the switch is closed. So Vc of t at t equal to 0 plus. So these two uh, voltages and current we know now, okay. And we know that as soon as the switch is closed, the voltage across the capacitor and the current across the inductor are not going to change. So how to represent this in a circuit? So let us see that one, okay. So you can see that this can be represented as shown here. You can see the switch is shown by just a conductor, and since the voltage Vc of t at t equal to 0 plus will be 0 volts as done earlier. So this can be represented by a conductor, okay, just by a conductor. And again the inductor current I, okay, this current I of t is equal to 0 at t equal to 0 plus, okay. So this current is also going to be there going to be 0, so this can be represented by an open circuit, okay. Now this can be further modified as shown here. Now I can further modify this circuit and it will be represented like this: 10 volts, okay, 3 ohms, okay. And this is the voltage we need to find, but you can observe here that these two resistors are in parallel, so which will constitute as 4 into 4 divided by 4 plus 4, okay. And we need to find this voltage VL of t, okay. So now if I further modify this circuit, what I get the further modified circuit as this has 10 volts, okay, and this has 3 ohms, and this resistor now if you calculate it, it comes out to be 2 ohms, and this is the voltage we need to find, VL of t. Now VL of t at t equal to 0 plus, okay. So VL of t at t equals to 0 plus will be equal to simple voltage division rule, so it will be 2 over 2 plus 3 into 10 or 2 into 10 over 5. This will give me 4 volts. Okay, hence VL of T at T equals to 0 plus is equal to 4 volts. So 4 volts is our answer to this question. Okay, so that's how you can solve this question. So thanks for watching.